Good morning to all. In today's class, we will discuss the programs on interfaces. Okay. So before going to discuss the programs on interfaces, first we will see what are the differences between concrete classes, abstract classes, and interfaces. These three are the containers in Java. So already explained, there are three containers in Java. They are concrete classes, abstract classes, and interfaces. So these three play a very important role in Java. So try to understand what are the differences between these three containers. Okay, already explained in the last class. We will revise once. Okay, after that we will go to programs on interfaces. So coming to concrete classes. So with respect to variables and methods, we will differentiate these three containers. Okay, if you take variables, so concrete classes consist of both final and non-final variables. Abstract classes consist of both final and non-final variables, but interfaces consist of only final variables. Now we are focusing on interfaces. That's why, so if you take interface consists of only final variables. It does not consist of non-final variables. Okay. Now, coming to the methods, concrete classes consist of only concrete methods. Abstract class consists of both concrete and abstract methods, but interfaces consist of only abstract methods. Okay. Now, if you take interfaces consist of only final variables and only abstract methods. That's it. So, what is an interface? And what is the syntax for writing interfaces? And how do we write the programs on interfaces? In today's class, I will cover all these concepts. So, interfaces consist of only final variables and only abstract methods. Now, you know the difference between concrete method and abstract method, and you also know the difference between final variables and non-final variables. Okay, if you know these concepts, then you can easily understand what are concrete classes, what are abstract classes, and what are interfaces. So throughout Java, we will study these three containers only. That's why try to write as many programs as possible on these three concepts. Okay, the entire Java covers only these three topics. That is, concrete classes means normal classes, and abstract classes and interfaces. These three are very important in Java. Next, already explained, interfaces contain only final variables and abstract methods. So what is the syntax for writing interface? So interface is a keyword like class name. Here we can write interface name. Okay, in the same way for class. So interface is a keyword and interface name is an identifier. So interface name, open brace, closing brace. Inside this, we will write only final variables and abstract methods. So this is the syntax for interface. So after understanding the syntax for interface, okay, try to write one example interface using the syntax. So here interface all lowercase letters because it is a keyword, and name of the interface I have taken it as I1. Okay, this is open brace. Here we have to write closing brace. Inside this, we will write only final variables and abstract methods. Here if you see this interface, here I have two final variables A and B and one abstract method M1. So final variables must be initialized at the time of declaring the variables. Means final variables are treated as constants. Once you assign the value for the final variables, you can't modify this value throughout that program. Okay, so these are called final variables and this is called M1 is called abstract method. So inside the interface, I can write only final variables and abstract methods. Okay, this is about interface. Next, so by default, what are available to interface variables and methods and interface. So by default, all the variables of the interface are public, static and final. So So whether you write or not for these two variables A and B, compiler will add, okay, public, static and final. So these three keywords are added by the compiler at the time of compilation for interface variables. So what are the three keywords which are added by the compiler at the time of compilation is, so for these two variables A and B, compiler will add three keywords. They are public, static and final. That's why by default all the interface variables are public, static and final. Okay. Next, in the same way, by default all the methods of the interface are public and abstract. Okay, you need not write public, static, final for interface variables, and again you need not write public and abstract for interface methods. Okay, the compiler will add by default these three keywords for variables and these two keywords for methods. Okay, next, for this interface we can add access modifiers. So by default the access modifier for this interface is default. But if you want to write explicitly any access modifier for the interface, we can use only public. So public interface we can write. You can't write protected interface or private interface. So by default the compiler will add, if you won't write anything for this interface, default. If you want to write explicitly, you can write only public. Okay. So this is about interface. So next, so this is the example for interface. It is a valid syntax. Why? Because here these two are variables A and B. Okay. These two are by default public, static and final, and one method is there, that is M1. This method is by default public and abstract, and this interface is by default access modifier. But if you want to write explicitly, we can use only public. We can't use protected and private access modifiers for interface. So try to understand interface syntax. Okay. Now after understanding the interface syntax, next concept is, next here you may get one doubt. Here we are writing inside the interface only abstract methods. So inside the interface we will write only final variables and abstract methods. We can't write concrete methods. So when you write only abstract methods inside the interface, somebody should implement the abstract methods now, because abstract methods do not have a method body. Means implementation is not there for abstract methods. When you write abstract methods inside the interface, somebody should implement the abstract methods of this interface. Now we will see who will implement or who will provide implementations to the abstract methods of the interface. This is the second important point to remember. First, write the interface, which consists of final variables and abstract methods. So after writing the interface, you should think who will implement the abstract methods of this interface. Okay, the answer for that is, there must be one class which must implement this interface. That class has to provide the implementations to all the abstract methods of that interface. Okay. So after defining, this is interface definition. So after defining the interface, you should take one class, okay, which implements this interface. So here between the class and interface, we use the keyword implements. Okay, not extends. Between the class and interface, we have to use the keyword implements. Okay, so after defining the interface, we should take one class which implements that interface. So first write the definition of interface. So interface I1, this is the definition of interface. So after writing the definition of interface, take one class which implements that interface I1. So inside this class definition, we have to give the implementations to all the abstract methods of the interface. Okay, so here class A implements interface. So between class and interface, we have to use the keyword implements. Okay, remember implements is the keyword which is used between the class and interface. So what is the role of this implementing class is, it has to provide implementations to all the abstract methods of the interface. So inside this class, we should give the implementations to all the abstract methods of the interface. In the same way, once you define the interface, any number of classes can implement that interface. So if you see this figure, this is interface definition. So after defining the interface, any number of classes can implement that interface using implements keyword. So what is the role of these three classes is, these three classes must provide implementations to all the abstract methods of this interface. Understand the concept of interface and implementing classes of that interface. After understanding these concepts, now here again third point. So first point is, first define the interface. Okay, next take the implementing classes. Okay, like A and B are the implementing classes which implements the same interface I1. This is the second point. First point is interface definition. Next second point is, we must take implementing classes which implements that interface. Third point is, now how do we access the members of this interface? Okay, third point is, how do we access the members of the interface? So the answer for this is, using upcasting, we can access the members of interface. What is upcasting? Okay, in case of interfaces, you know upcasting concept in case of abstract classes. Like that, we should know the upcasting concept with respect to interfaces. So what is upcasting with respect to interfaces is, so this is, I am saying this is, here A and B are implementing classes, no? So implementing class object is assigned to interface reference variable. So with that reference variable, we can access all the members of the interface. Understand upcasting with respect to interfaces. So in abstract classes and in interfaces, we use upcasting concept. That's why inheritance is required to understand abstract classes and interfaces. So in inheritance, we studied upcasting concept. What is upcasting concept in inheritance is, subclass object is assigned to superclass reference variable. That is nothing but upcasting. Only upcasting we can discuss with respect to inheritance. But in case of abstract classes and interfaces, we must use upcasting to access the members of the abstract classes and interfaces. We must use upcasting. That's why you should understand upcasting first with respect to inheritance. After understanding upcasting concept in inheritance, okay, we use upcasting concept in both abstract classes and interfaces. Okay, so what is upcasting with respect to interfaces is, implementing class object is assigned to interface reference variable. So here I am repeating the same statement again. For abstract classes and interfaces, we can't create objects with new operator. Okay, for abstract classes and interfaces, we can't create objects with new operator. Then without creating objects for abstract classes and interfaces, how do we access the members of abstract classes and interfaces? That is the question now. So to answer this one, okay, what is the answer for this is upcasting. Using upcasting, we can access the members of both abstract classes and interfaces. So for interfaces, we can't create objects with new operator. Okay, without creating objects for interfaces, we can't access the members of the interface now. Now that's why the solution for this problem is, okay, upcasting. So using upcasting, we can access the members of the interface. So what is upcasting with respect to interfaces is implementing class object is assigned to interface reference variable. For interfaces, we can only create reference variables. We can't create objects like abstract classes. That's why we implementing class object. But for implementing classes, we can create objects. But for interfaces, we can't create objects. That's why we will take upcasting. So with the help of upcasting, we can access the members of the interface. So here what is upcasting with respect to interfaces is subclass object is assigned to interface reference variable. With this implementing class object, we can access the members of this interface. Okay. So through the implementing class object, we can access the members of the interface. So with respect to interfaces, remember 3 points. If you understand these 3 points, okay, it is very easy to write the programs on interfaces. You can write on your own if you understand the concepts. Don't by heart the programs. That's why try to understand the concepts on interfaces. Here we should remember 3 points only with respect to interfaces. So first point is, first define the interface. Second point is, take implementing class. That is, take one class which implements that interface. That is second point. Third point is, for interfaces we can't create objects. We can only create reference variables. That's why using this implementing class object, we can apply upcasting. So what is the upcasting with respect to interfaces is, okay, implementing class object is assigned to interface reference variable. With that reference variable, we can access all the members of the interface. So how do we access the members of the interface without creating the object for interfaces? Through implementing class object. So that is nothing but upcasting. So what is upcasting is, implementing class object is assigned to interface reference variable. With that reference variable, I can access all the members of the interface. If you understand these 3 points, okay, with respect to interfaces, you can write any number of programs on your own. So again, I am repeating the 3 points. First point is, define the interface. How to define the interface is, interface is a keyword, S is not there here. Interface name. So open brace, closing brace. Inside the interface, write only final variables and abstract methods. That is the first point. Second point is, after defining the interface, take one class which implements that interface. So inside this class definition, provide the implementations to all the abstract methods of the interface. That is the second point. Third point is, for interfaces we can't create objects. We can only create reference variables. That's why we need to use upcasting concept with respect to this interface and this implementing class. So upcasting is nothing but implementing class object is assigned to interface reference variable. With that reference variable, we can access all the members of the interface. This is the third point. If you understand these 3 points, okay, we can easily write the programs on interfaces. Okay, here same third point, here I have given the explanation. Next, we will start writing the programs on interfaces. Okay, so here how many ways are there to write interface programs? There are 7 ways. Means we can write 7 programs using interfaces. First I will explain these 7 types. After that I will explain some of these programs. Okay, you try the remaining programs. Once you understand the concept, it is easy to write the programs. Okay, now there are 7 ways to write the programs on interfaces. What is the first program? Create one interface. Next, take one class which implements that interface. This is the simplest program on interfaces. Okay, first define one interface. interface name, and inside the interface write only final variables and abstract methods. So after defining the interface, take one class which implements that interface. Inside this class, provide the implementations to all the abstract methods of this interface. Because interfaces consist of only abstract methods. Abstract methods do not have method body. Somebody should provide implementation to abstract methods. Who will provide the implementations to abstract methods of this interface is this class A. So class A must provide implementations to all the abstract methods of that interface. So this is the first program. First define one interface and take one class which implements that interface. Okay, this is program 1. Next, second program is define one interface. Next, after that I explained now. Once you define the interface, any number of classes can implement that interface. So here in the first program, I have used only one class which implements that interface I1. But in the second program, I am taking two classes, okay, which implements that interface. Okay. And now here first define the interface. After that, I am taking two classes. Okay. And now class A implements I1. Means inside the class A, we must provide implementations to all the abstract methods of this interface I1. Next, class B implements I1. So here A implements I1, B also implementing the same interface I1. Inside class B also, we must provide implementations to all the abstract methods of this interface I1. This is the second program on interfaces. Next, third program is, we can create multiple interfaces now. In the first two programs, I have created only one interface. But in the third program, I am defining two interfaces. They are interface I1 and interface I2. Okay. Next, what I am doing here is, I am taking one class which implements both the interfaces. See, this is the new point in interfaces. So class A implements I1, I2. Means one class can implement any number of interfaces, but one class can extend only one class in inheritance. One class cannot extend more than one class. Means multiple inheritance is not possible. Means one class cannot extend more than one class, but one class can implement any number of interfaces. Understand this point here. So that's why through interfaces, we can achieve multiple inheritance. Multiple inheritance is nothing but one class can extend any number of classes. But in Java, the Java does not support multiple inheritance. But through interfaces, we can achieve multiple inheritance. Means one class can implement any number of interfaces. Now remember 2 points. One class cannot extend more than one class, but one class can implement more than one interface. Means in Java, through interfaces, we can achieve multiple inheritance. This is interview question. Because in Java does not support multiple inheritance, how do we achieve multiple inheritance in Java? This is important question. So the answer for this is, through interfaces, we can achieve multiple inheritance in Java. What is that? One class can implement any number of interfaces. Okay. That's why here I am defining two interfaces. I am taking one class which implements two interfaces. So how do we take these two interfaces is separated by comma. Like that I can define three interfaces I1, I2 and I3, and class A implements I1, I2, I3. Like that one class can implement any number of interfaces. This is very, very important concept in Java. Through interfaces, we can achieve multiple inheritance. Because Java does not support multiple inheritance, and in one class cannot extend more than one class, but one class can implement any number of interfaces. These are the very, very important points. Okay. Now here one class can implement any number of interfaces. Because of that, here I am writing class A implements I1, I2. Now what is the role of class A is, class A must provide implementations to all the abstract methods of both I1 and I2. That's it. Okay. Because inside I1 we will write some abstract methods, and inside I2 also we will write some more abstract methods. Now here inside the class A, we will provide the implementations to both the abstract methods of I1 and I2. Okay, this is third program. If you understand the concept, you can write the programs on your own. Don't by heart the programs. Next, what is the program? What is the fourth program? Next, I am using both extends and implements keyword in the same program. Okay. Now, how do I use extends and implements keywords in the same program is, first I will define two interfaces I1 and I2. Next, I will define one class A. Next, after defining these three, that is two interfaces and one class, I will take one more class B, which extends A and implements I1, I2. This is important program. Here we are using both extends keyword and implements keyword. Extends keyword is used between two classes and implements keyword is used between class and interfaces. Okay, that's why first define two interfaces I1 and I2 and one class A, and after that class B extends A, because BA is a class, no? So between classes we have to use extend keyword. Okay, so class B extends A. This is nothing but inheritance. Class B extends A. It is inheritance. Next, followed by I am writing implements I1, I2. What is the meaning of this is, okay, the class B is extending class A and implementing I1 and I2. Two interfaces. Okay, this is for this also we can write one program. Next, fifth program is interfaces can also be extended like classes. See, here we are writing between two classes extends keyword, no? Means two classes can be extended, no? Like that, two interfaces can also be extended. How do we write the extend, or how do we use the extends keyword with respect to interfaces is, this is fifth program. Okay, so define two interfaces I1 and I2 with final variables and abstract methods. After that, means this I2 is, here we are writing in I2 using extends I1. Means define one interface I1 with final variables and abstract methods. After that, interface I2 extends I1. What is the meaning of this is, interface I2 extends I1 means, so in I1 we are writing final variables and abstract methods, no? So all the final variables and abstract methods of this interface I1 are inherited to this interface I2. After that, inside interface I2, we can write our own final variables and abstract methods in I2. They are own to I2. In addition to the own variables and methods of I2, it can inherit from the interface I1 using extends keyword. So inside the interface I2, we have the members of both I1 and I2. So between two interfaces, we can use extends keyword. That's why here first define one interface, next define one more interface, that is interface I2 extends I1. Means all the final variables and abstract methods of I1 are inherited to I2. In addition to those inherited members of I1, interface I2 can write its own variables and methods. Okay, this is the concept of two interfaces can extend, or two interfaces can be extended. Next, that is fifth program. Next, sixth program is one interface can extend any number of interfaces. Here in the fifth program, one interface extends only one interface, no? But one interface can extend any number of interfaces. So for that, we use sixth program, that is, I am defining two interfaces I1 and I2. After that, I am taking one interface I3 which extends I1, I2. Means, so all the members of I1 and I2 are inherited to I3. Extends means inherited. Use the word inherited. So here all the members of I1 and I2 are inherited to this interface I3. Okay. So here I am defining two interfaces and I am using extends I1, I2 with this interface I3. So one interface can extend any number of interfaces. Okay. This is like multiple inheritance. Between interfaces we can use, but between classes we can't use like this. So one class cannot extend more than one class, but one interface can extend more than one interface. Next, that is sixth program. Seventh program is, so here I am taking one interface and one abstract class. So here abstract class A implements I1. Why do we take here abstract class is, suppose the class A doesn't want to provide implementations to all the abstract methods of the interface. Then in that case, the class must be declared as abstract. Next, already you know abstract classes concept, no? If abstract class is there, then there must be one class which extends the abstract class. So this class will provide the implementations to the remaining abstract methods of this abstract class. Okay. So here what is the concept in the seventh program is, first define one interface with final variables and abstract methods. Let us take 5 abstract methods in I1. But here the class A which is implementing the interface I1. But class A doesn't want to provide the implementations to all the 5 abstract methods of I1. It will provide implementations to only 3 methods. It will not provide the implementations to the remaining 2 abstract methods of this interface. Then in this class A we have abstract methods, 2 abstract methods. So if any class which contains abstract methods, then that class must be declared as abstract. That's why here I am declaring the class A as abstract, because class A consists of abstract methods. Okay. Next, after defining this class as A as abstract, there must be one class which must extend this abstract class. That's why I have taken one more class B which extends that abstract class. Inside this class B, I will provide the implementations to the remaining 2 abstract methods of this abstract class. Okay, this is the 7th program. So like this, we can write the programs on interfaces. Okay, so we can write 7 ways. Okay, or we can write 7 different programs using interfaces and classes. If you understand these concepts, so take the first program and give the code. First, we will discuss. I will explain some of these programs. With that concept, you can write the code for the remaining programs. We will start the programs on interfaces. So here, see, between the classes and between the interfaces, we can use extends keyword. But between class or between interface and class, we use implements keyword. So these 2 keywords are very, very important with respect to classes and interfaces. So inheritance is very, very important. Okay. So after inheritance, we will go for abstract classes and interfaces. So here the order we should read Java is, first one is concrete classes, means normal classes. How do we write a class in Java with state part and behavior part? That is nothing but concrete class. There is no concrete keyword. Write the classes with state part and behavior part. First, try to understand how to write the normal classes, that is concrete classes. And how do we create objects after writing the class? That is the first one. After that, in the sequence, we have to study inheritance. Inheritance is nothing but between 2 classes, we can use extends keyword. Use extends means all the members of one class can be inherited to another class. So using superclass and subclass concepts, we use inheritance programs, or we will write the inheritance programs. So first understand concrete classes, then inheritance, then abstract classes, then interfaces. This sequence is must. Otherwise, you can't understand Java. First one is concrete classes. Okay. Then write the programs using concrete classes. Then inheritance. Write the inheritance programs using concrete classes. In inheritance, try to understand the concept of upcasting. Okay. Next, after that, abstract classes. For abstract classes, we can't create objects. We can only create reference variables. That's why we must use upcasting concept of inheritance in abstract classes. Next, interfaces. For interfaces also, we can't create objects. We can only create reference variables. That's why to access the members of the interfaces, we must use upcasting. That's why the order is concrete classes, inheritance, and in inheritance, understand upcasting. Next, abstract classes, use upcasting concept in abstract classes. Then interfaces, again use upcasting concept in interfaces also. Because for abstract classes and interfaces, we can't create objects. So without creating objects for abstract classes and interfaces, we can't access the members of the abstract classes and interfaces. That's why with the help of upcasting, we can access the members of the abstract classes and interfaces. That's why try to understand upcasting concept. Now we will start writing the programs on interfaces. So what is the first program? First program, see, here the concept in the first program is take one interface and take one class which implements that interface. Okay, already explained 3 points with respect to interfaces. No? First define one class, one interface. Next define one class which implements that interface. First point is define one interface like this, and the second point is define one class which implements that interface, and the third point is take one more class and inside the main method of that class using upcasting, okay, we will access the members of the interface. This is upcasting. This is the third point, very, very important point. So to access the members of the interface, we must use upcasting concept in both abstract classes and interfaces. This is the third important point. Again, I am repeating the 3 points. First, define the interface. Next, the second one is take one class which implements that interface. And the third point is to access the members of the interface, okay, use upcasting like this. If you understand these 3 points, it is very, very easy to write the programs on interfaces. Okay. Now I will explain program 1. First point is I will define the interface like this. Now interface is a keyword and the name of the interface is I1. So inside this body, I will define final variables and abstract methods, because the interface consists of only final variables and abstract methods. So here I am taking only one final variable, that is A. So you need not write public static final. If you write also correct. If you write one keyword also correct, or if you write 2 keywords also correct, if you write all the three keywords also correct, or if you won't write anything also correct. You can write only int A is equal to 10. By default, all these 3 are available for this variable A. Okay, compiler will add these 3 keywords to this variable at the time of compilation. Okay, final variables must be initialized at the time of declaring the variable. Means it is like constant. Okay. Next, here I am taking 2 abstract methods, M1 and M2. You know abstract method syntax, return type, name of the method with parameters or without parameters, and the method is declared with abstract keyword and ends with semicolon. Okay, so here I have taken 2 abstract methods. If you write only void M1 and void M2 also correct, by default these 2 keywords are available for all the methods of the interface. So this is the definition of the interface. This interface I1 consists of only one final variable A1 and 2 abstract methods M1 and M2. Okay, that's it. So this is the syntax for writing interface. After that, coming to the second point. What is the second point? There must be one class which implements that interface. Otherwise, what is the use of defining this interface? When you define the interface, after that you have to take one class which implements that I1. Okay, that is the syntax for that is class A implements I1. So inside the class A, okay, I have to provide the implementations to all the abstract methods of the interface I1. Here we know that there are 2 abstract methods in I1. That's why class A will provide the implementations to these 2 abstract methods. That's why here we will see. What is the role of class A is, it will provide the implementations to the abstract methods of the interface I1. Here we know that we have 2 abstract methods. That's why inside class A, I will provide the implementations to the 2 abstract methods of I1. So this is the implementation for M1. and this is the implementation part for M2. In addition to M1 and M2, this inside class A, it can write its own methods like M3, M4, M5 like that. But these two are must. The class A must provide implementations to all the abstract methods of the interface I1. That's why it has provided the implementations to both M1 and M2. Okay, this is easy only, no? So void M1 and inside that it is ASM1 method, and void M2 it is ASM2 method. You have to take the same return type and the same parameters when you give the implementation part for those two methods. That's why I have taken void M1. Now here you may get one doubt. Here I am declaring this method as public. Means I am using the access modifier public for this M1 method. Why we should use public? It is must. Why it is must, I will explain here. Here one concept is there. The access modifier of the subclass. This is in inheritance. You will get this concept. In overriding, already explained overriding methods now. So in case of overriding methods, you have to remember this point. So the access modifier of the subclass overriding method must be greater than or equal to the superclass overridden method. Already you know the difference between overriding and overridden method. Always subclass method is called overridden method. Subclass method is called overriding method. Superclass method is called overridden method. Already explained in depth about these two types of methods in inheritance in the concept of overriding. Okay. So here what is the new concept you have to remember with respect to overriding is the access modifier of the subclass, the access modifier of the overriding method must be greater than or equal to the access modifier of the overridden method. Actually here you need not write subclass and superclass, because always overriding method is with respect to subclass and overridden method is with respect to superclass. So here what is the rule is? The rule is that the overriding method of the access modifier of the overriding method must be greater than or equal to the access modifier of the overridden method. Okay. So with this point, and you know one more point, that is always private is less than default, less than protected, less than public. Means with respect to scopes, we can write like this. Private is having less scope when compared to default. Again, default is having less scope when compared to protected. Similarly, public is having more scope when compared to private, default, and protected. Okay. So with this, I will explain this concept with these 2 points. So already I will explain the access modifiers, or I will explain these 4 access modifiers in depth when we go to packages. After inheritance, the next concept is packages. Okay. While explaining the packages concept, I will explain these 4 access modifiers. Now remember, with respect to scope, private is less than default, less than protected, less than public. Like this, you remember. Now, so with this and with this rule, I will explain why we should take public for M1 inside class A. Okay. Now we will see the access modifier of the overridden method. So this M1 method is called overridden method, and this M1 method is called overriding method. Okay. So with respect to overriding and overridden method, we should remember this point. The access modifier of the overriding method must be greater than or equal to the access modifier of the overridden method. Now we will see what is the access modifier of the overridden method. Already it is by default, it is having public. If you write also, we have to write public only, because all the methods of the interface are by default public and abstract. So here this overridden method is having the access modifier public. Now when you write the access modifier for the overriding method, you should follow this rule. So what is the rule? The access modifier of the overriding method must be greater than or equal to the access modifier of the overridden method. So here the access modifier of the overridden method is public. So here you have to write the greater than or equal to access modifier for overriding method. So public is the last one, no? This is the highest one, no? So when you write the access modifier for the overriding method, you should write only public. There is no other alternate. Greater than or equal to. See, this is the last access modifier, no? That's why when you use this rule, it must be public. Suppose if you write protected here, what will happen? Protected is having less scope than public, no? Means protected is less than public. Less than we can't write. Only greater than or equal to we should write. That's why when it is public, it must be public. Means we are using equal concept. We can't use less than here. We must use either greater than or equal. Because public is the last access modifier with respect to scope. That's why we should use, when it is public, here it must be public. So that is the reason why we should write public for the overriding method of this class A. Okay. So because it must be public, it is public always, then it must be public. If you do this program with protected or private or default means don't write anything here. So if you use any access modifier other than public, that is either private or default or protected, definitely you will get compiler error. Because Java developers have given this rule with respect to overriding and overridden method. That's why in case of overridden method, if it is public, in case of overriding method, it must be public. Okay, because of greater than or equal to. Here we are using equal. Public means both are equal. So that's why whenever you provide implementations by abstract methods of the interface inside this class A, we must use public here. Okay. That's why here I am providing implementations to both abstract methods M1 and M2 inside class A. That's why here what we should write, public void M1 and provide implementation. Again public void M2 and provide implementation. So this is the important point to remember with respect to overriding methods inside class A. So this is the second point. First point is define the interface. Second point is take one class which implements that interface. Inside that class, provide implementations to all the abstract methods of that interface. Next, third point. Third point is how do we access the members of this interface? Because when we define the interface, we need to access the members of the interface now. So what are the members of this interface? So here A is the member of the interface and M1 and M2 are also the members of this interface. So I1 has three members. They are A, M1, M2. Now, so after writing the interface and after writing the class A which implements I1, okay. And now next question is how do we access the members of this interface? So the answer for this is upcasting. Okay, now I am using the concept of upcasting to access the members of the interface. Okay, for that I am taking one more class. Okay, inside that class I will use main method. So main method is must. So inside the main method I am using upcasting concept. Through upcasting I can access the members of the interface. You know the members of the interface are one final variable and two abstract methods. Okay. Now I want to access the members of the I1. So how do I access the members of the I1 is using upcasting. So what is upcasting? Already explained. So in case of interfaces, implementing class object is assigned to interface reference variable. Because for interfaces we can only create reference variables like this. We can't create objects like means I1 is equal to new I1 I can't write here. So for interfaces, we can't create objects with new operator. Means new I1. In place of A, if you write this capital I1, that is compiler error. Why? Because for interfaces, we can't create objects with new operator. So without creating the objects for interfaces, how do we access the members of the, or how can we access the members of the interface? There must be some solution for this answer, for this question, no? So what is the solution for this question is, without creating the objects for the interface, how can we access the members of the interface is, the answer is upcasting. What is upcasting is, this is upcasting. So implementing class object is assigned. This is the object for the implementing class. Here already explained, interface is interface is I1 and implementing class is A. Implementing class means this class is providing the implementations to these two abstract methods of this interface. So with respect to this I1 and this implementing class A, I will use upcasting. So what is upcasting with respect to I1 and A is, so this is the object for the implementing class A. So implementing class object is assigned to interface reference variable. So for interfaces, we can only create reference variables like this. We can't create objects with new operator. The same concept is valid for abstract classes also. So for abstract classes and interfaces, we can't create objects. We can only create reference variables. That's why in case of abstract classes and interfaces, we must use upcasting. There is no other alternate. That's why if you understand upcasting, then only you can understand abstract classes and interfaces. Okay. Next. So what is upcasting in case of this interface and this implementing class A is I1 is equal to, means this is the reference variable for this interface I1. We can only create reference variables for the interfaces. I1 is called reference variable for this interface I1. Only this is possible for interfaces. After that, this is the implementing class object. Object means right hand side. Whenever you use new operator, memory is allocated for this. That's why this is called object. So here we have created object for implementing class, and implementing class object is assigned to interface reference variable. This concept is nothing but upcasting. So what we do with upcasting is, with this reference, now with this is upcasting, no, that is implementing class object is assigned to interface reference variable. With this reference variable, I can access all the members of the interface except overridden methods. Remember this point. With this reference variable, I can access all the members of the interface except overridden methods. What are the members of the interface? Here we have 3 members inside the interface. So with that reference variable small I1, I can access only A, M1 and M2. I can't access the implementing class members. Suppose if you write M3, which is there in class A, we can't access M3. You see here I have written. The one method to class A is add this method also. Okay. So inside class A, in addition to providing the implementations to the abstract methods of M1 and M2 of I1, it is writing its own method, that is M3. M3 is the own method of class A. So here this is M3 method which is own to class A. But with this reference variable I1, I can access only the members of the interface. The interface members are A, M1 and M2. I can access only with this reference variable the interface members. They are A, M1 and M2. Now we will see. So what we can access with I1 is, we can access only interface members. That is A we can access, final variable A we can access, M1 and M2 we can access. That's why I have written I1.M1 correct, I1.M2 correct, because M1 and M2 are members of the interface. But when you write I1.M3, you will get compiler error, because M3 is not a member of the interface I1. That's why it is error. So remember, with this reference variable, we can access only the members of the interface. We know that there are 3 members inside the interface. They are A, M1 and M2. That's why with I1, means with this reference variable, I can access M1 and M2 and only A. A can also be accessed with this I1. Next here also I1.M1, I1.M2 and I1.A up to this correct, because with this reference variable I1 we can access only 3 members. They are A, M1 and M2. I can't access this implementing class member I3, M3. Okay, next here I have written one more thing, that is I1.A. What is this I1.A? I1 is interface name, no? Here I am accessing the variable A using the interface name also, in addition to the reference variable. But how we can access like this is already explained in the last class, static variables. See, if you see the variable A, it is declared with static keyword. So static variables can be accessed 3 ways. inside the class or two ways outside the class. So here this is outside the class. No, there are two ways to access the static variables outside the class. Outside this one, outside this, outside means inside class here we are using a, no. So the static variables of one class can be accessed outside the class two ways, that is using reference variable and using class name, because here a is declared with static. That's why outside the class means outside that interface, class or interface. So outside the interface I can access the static variable of that interface two ways, with reference variable, that is I1.a, and with class name or interface name. That's why here I1.a. So with interface name also I can use static variable of that interface, or with reference variable I1 also I can access. That's why there are two ways to access the static variables of the interface, that is with reference variable or with interface name, like class name. So this is the third point. In the third point is nothing but upcasting. After that, here I have created object for implementing class also. Through this implementing class object, I can access all the members of class A. Means I can access A is inherited. No, implements means like inheritance only. The final way, the variable of interface A is inherited to class A. So that's why against A is static variable. No, with class name I can access, and with reference variable I can access. So this is the object creation for the implementing class A. That is A1 is equal to new A. So with this reference variable I can access all the members of the class A. Here like inheritance, when the class implements the interface, all the variables are inherited to the class A. That's why I can use the variable, because A is available for class A also. That's why, because A is a static variable, I am using two ways, that is with class name and with reference variable. Means this. After that, what are the members of class A? M1, M2 and M3 also there. So with A1 I can access M3, but with I1 I can't access M3, because upcasting is saying that with this reference variable I can access all the members of the interface only. All the members of the interface only. M3 is not a member of the interface. That's why with this I1 I can't access M3. You remember these points. Okay. So here, so with this reference variable A1 I can access A, M1, M2, M3. So with this the first program is completed. If you see the output, you will get this output. Okay. Now first program is completed. In the next class I will explain some more programs. With those programs you can understand interfaces more clearly. Okay.